Welcome back to the channel Byte, dear students. Today we are going to look at the fourth type of sorting algorithm, which is the quicksort. As its name implies, quicksort is one of the fastest sorting algorithms. It is another example of the divide and conquer approach to problem solving. So the quicksort is a sorting algorithm that makes use of a divide and conquer approach. How does it work? Select an element, which is the pivot, from the array element, but note that the pivot is always the first element. Rearrange the elements in the array as follows. All elements that are less than the pivot appear before the pivot. All elements greater than the pivot element comes after it. Equal values go either way. So this is how we are arranging the elements around the pivot. After such a partitioning, the pivot is placed in its final value. This is called partition operation. Recursively sort the two subarrays thus obtain, one with sublist of values less than that of the pivot element and the other having higher value elements. The technique, which is the most important, how to sort an array using the quicksort. Sort the list 4, 3, 1, 5, 9, 7, 10, 6 in ascending order using the quicksort. So this is what we have. This is the left. As you can see, the left is always the first element, just like the pivot, and the right is the other end. How do we work? We scan from right to left, that is from this side to this side, and we stop when we have the first right value that is less than the pivot. So what do we have? I take this value and I compare with my pivot. If it is greater than, I keep on comparing until I will have the first value that is less than this pivot value, which is 4. So now when you compare 6 and 4, 6 is greater, we move to 10. 10 is greater, we move to 7. 7 is greater, we move to 9. 9 is greater, we move to 5. 5 is greater, when we move to 1. This is our first value from the height that is less than our pivot. So what happens? This is where height will end, because when we scan from height to left, this was the first value we had. So this is where our height value stops. And what happens? When such happens, since our pivot is greater than the height, we interchange the two values and we set our pivot to height. So I will interchange 1 and 4. Then pivot becomes this new value. As you can see, so we interchange the two values first of all. So 1 enters here, 4 enters here. Then we set our pivot to height. So pivot leaves from this place and comes here. And this is what we are going to have. As you can see, the two values has been interchanged and pivot left from 4 and came to right, as you can see. Now, as pivot moved, what do we do now? We start scanning now from the left to right until either left is equal to pivot. So we are ending when left is equal to pivot, that is left and pivot will be at the same place. If at any point left is greater than pivot, we swap and we set pivot to left, just like we did with height. So when you compare 1 and 4 less than, you compare 3 and 4 less than, so you are going to stop at this level because these two values are less than the pivot and left will enter here, and we said that we are scanning until left is equal to pivot. So as you can see here, 1 is less than, left came here, still less than, it came here now. So you see that at this level left and pivot are the same, so that's where we end. This shows that pivot is now at its right place, as you can see, because all the values less than the pivot are below and all the values greater than the pivot are above, as you can see. So this is the right position of the pivot. So now this makes our list to be divided into two sublists, because this is the left sublist and this is the right sublist, and we have to sort each of them. Now, if we start with the left sublist, that is 1 and 3, this is what we have. What do we realize? When we scan from height to left, we see that this is greater than the pivot, so height enters here, and now they are the same, and it is already sorted since left is equal to pivot and there is no item on the left of the pivot, as you can see. So this is already sorted. Understand, we scan from height to left. When you compare 3 and 1, 3 is greater, so height comes here. And now since height and pivot are the same, I start now from the left. When you compare 1 and the pivot, first of all, there is nothing to compare since left and pivot are already equal, and there is no value to the left of the pivot again. So this is already sorted. When we move now to the right sublist, this is the high sublist 5, 9, 7, 10, 6. So our pivot on our left is the first element, while the right is the last element, as you can see. When you compare, 6 is above, 10 above, 7 above, 9 above, and also pivot and left are equal, and there is nothing again. So this pivot is already at its correct position, as you can see. So scanning from right to left, all the values are above pivot and the left is equals to the pivot. So this pivot is at the high position. Now we have to sort again the right sublist, as you can see here, because there is no left sublist, there is only the high sublist. So you have to sort this right sublist again. So now, what do we have? First of all, let us come back at the beginning. This left sublist, this is that is already sorted. This is our pivot that we had. From this place, this is the pivot that is at the correct position. This is it there. And this is the right sublist that we have to sort, as you can see. So this is my left, my pivot, my right. When you compare, you see that this is already the first value less than the pivot, because when we scan from right to left, once we have the first value that is less than the pivot, we interchange and we set pivot to that value. So I will interchange 9 and 6 and pivot will enter here. This is what we are going to have, as you can see. So 9 and 6 has been interchanged. Good. So this is what we are having. Now we scan now from left to right. Once we have the first value greater than the pivot, we interchange. And if at an instance pivot is equal to left, that's where we stop. As you can see, this is it. Scan from left to right until left is equal to pivot. If at any point left is greater than pivot, swap and set pivot to left. So here, 6 is less than, 7 less than, but 10 is greater than. So I'm going to swap these two values and pivot will enter here, as you can see. So this is what we have. So because at this level, this is the first value from the left greater than the pivot. First of all, swap them, as you can see. Then pivot takes that value. So it's just like the pivot is moving with its value, as you can see, which is the same thing here. When pivot was moving, it was moving with its value. Pivot 4, pivot 4, pivot 4, pivot 4. Here our pivot was 1. This is it here. Pivot 5. Here pivot is 9. It is moving, as you can see. Good. So now we realize that pivot is equal to left. So we end and we see that it is at the right place and both left and right sublists are sorted. So our list is fully sorted. We have 1, 3, 4, 5, 6, 7, 9, 10. So this is our sorted list. So that is how the quick sort is working. Moving down to the complexity of the quick sort. In the best case, each time the list is partitioned, it is divided neatly into two sections of equal size. This means log 2 nested calls, because we realize that if it is using a for loop, at every iteration we are dividing the loop into we are dividing the list into two, meaning that our counter increases by a division of 2, and that is a logarithmic loop. That's why we say it means log 2 nested loop will be needed before the partition size is 1. Therefore, the best case time complexity is what? O(n) log n. The worst case is encountered when the pivot value is in the first or the last position of the current partition, as this will result in one partition with 0 element and another partition having all the remaining element. That's the worst case. Starting with n-1 element, if this happens repeatedly, the next step will result in a partition with 0 element and another with n-2 element, and so on. As a result of this, the time complexity is classified as O to the n squared. Correct. Now, as with most sorting algorithms, the average case time complexity depends on many factors, like the initial choice of pivot value and how out of order the original list is. However, it is generally agreed that on average, performance will be big O n2 to the log n, and complexity of the quicksort, since we always base ourselves on the worst case, the complexity of the quicksort is O to the n square. But take note, dear students, if in a paper 1 you are being asked the best case or the average case, it is big O to the n log n, but in general its complexity is O to the n squared. algorithm for a quick sort, this is what we have. These are our variables, the left, the right, the pivot, the flag. We have our list indexing starting from 0. So we initialize left to 0 and right to n minus 1, just as it was done in the technique. As you saw, we have our pivot taking the first element as well. Then we have our flag, which we are going to use to know whether our list is already sorted. So this is the condition that we have for height to be moving. This is the same thing we have for the left, as you can see here, and all is done. We are going to better understand these sorting algorithms when we shall be working in programming in C after doing the introduction, doing the different construct we have and subroutines. We are going to evaluate all these different sorting algorithms whereby you will fully understand during the different dry running. And I hope the technique the quicksort uses in sorting an algorithm was well understood. In the next lesson, which will be the last, we shall be seeing the last type of sorting algorithm, which is the merge sort. Okay, a small notice. Quick note is faster than other algorithms such as bubble sort, selection sort, and insertion sort. Also, quicksort can be used to sort arrays of small size, medium size, or large size. On the flip side, meaning on the other case, quicksort is complex and massively recursive. Take note, dear students. So this is what we have for our next and last lesson. Thanks for watching the video. Do not forget to like, to subscribe, and to share for our community to grow. Thank you very much.